Hybrid Cloud Show, episode 23. I'm Aaron.
I'm Gary.
I'm Sean.
And I'm Shane.
Welcome to the show about public cloud, private cloud, and everything in between. Our views here are ours and not those of our employers. So I'm going to start by asking you a question. Do you think that being cloud first is more about the target for your workloads or more about mindset? Another way of putting it, can you be a cloud first developer who only targets private infrastructure, or can you be old school and still target development in the public clouds?
So I guess to answer the second half of that question, I think you can be old school and target deploying workloads in the public cloud, but you probably shouldn't. As in, if you're going to just use the cloud as a place to deploy your Linux or Windows VMs with your workloads on, that probably isn't the most optimal way to use cloud, and that it's probably more cost efficient to do that on premises, because you're not really taking advantage of all of the things the clouds have to offer.
And to answer your first part, I think you can absolutely be a cloud engineer or cloud-centered engineer and develop for a private environment. I mean, that's what hybrid cloud is all about sometimes, right? As long as you're using the cloud-native tools, the cloud-native technologies, just deployed on-prem, that's a win.
There's a scaling issue there of like, let's say you need something with like global redundancy, multiple AZs across multiple regions. Like it hits a limit, but definitely if you've got the right type of problems, then absolutely you can use cloud tech. That still might be more scalable than just hand rolling everything. Could you at least using the same types of technologies if you need that global scale? And if you don't, then great.
Yeah, one of the things that sprung to mind for me, if you've got a workload that's particularly spiky, or you get very short notice of increases in number of requests and things, that is probably really difficult to do on-prem, unless you've got the hardware sitting there waiting to spin up a bunch of other VMs and add them to your pool in your load balancer, in which case, again, probably quite a wasteful way to run on-premise compute. That stuff is just much more possible in the cloud. If we think about things like Lambda, where you can just scale those functions, not infinitely, but really quickly up to millions of requests per second if you need to. That stuff is just the kind of thing that in the on-prem world takes a lot more planning and a lot more preparation. I've seen particular workloads where companies get 20 minutes notice that a marketing campaign is running and they need to be ready to run at that scale within that 20 minutes, process those click-throughs from the marketing emails, take those orders, whatever it might be. And I don't know about you guys, but scaling from standard website load to millions of requests per second on-prem is not something I could do within 5 to 10 minutes.
They were given 20 minutes notice. Wow, look at them. I usually find out 20 minutes after when everything goes down and it's all gone to shit. That's good.
You start seeing all of those logs come through and go, what the hell is this spike in traffic? Oh, the marketing team.
I don't want to turn this into the same sort of gatekeeping discussions that we've had on the other shows around like what is Linux, what is a Linux developer. That wasn't sort of where I was going with it. But I am interested in a slight expansion of what you were just talking about there, where I think, Sean, you were going to go to things like the tools, like the infrastructure as code side of things. But I think, Gary, you were talking more some of those more cloud-specific things like Lambda. And I'm interested where you all draw that line between what is it that you think actually makes something cloud-first or cloud-native as opposed to just being in the cloud.
I think for me, it's around the way that you build the application to begin with. So rather than building these tightly coupled monolithic services that we often see on-prem, where you've got a front-end tier, you've got a database tier, and yeah, that kind of standard 3-tier web application that we're all familiar with at this point. It's when you're building small components that are loosely coupled, that are resilient to faults, issues in a specific AZ. They've got things like retry, exponential backoff. It's really going back to those fundamental principles of what building in the cloud means to be, rather than deploying and building an application in the same way as you would have done before the cloud existed.
I think that's interesting, right? Because some of those pieces, like the infrastructure as code pieces are relatively straightforward on-prem, whereas multi-AZ might be quite hard depending on, the layout of your data centers or your physical infrastructure. So it's an interesting piece where clearly if you're using containers and Kubernetes and those sorts of things, you're going to find it easier to split up some of your infrastructure. But it does get interesting when you only have one data center or one home cloud. Can you do that in a sort of cloud native way?
I guess in the cloud world, you've got to assume that, I guess to borrow a phrase from Amazon's CTO, that everything fails all the time. Don't assume that you're going to call an API endpoint and that it's going to respond in the time or the way that you expect it to. Don't assume that just because you've put a message in a queue that it's going to be processed in the amount of time that it should be. It's planning for failure and actually in a lot of cases assuming failure, which I think in on-prem development models we often don't think about, right? Because it's, we can blame the sysadmin because that server was down or we saw packet loss across that piece of network connection, so that's the network team's fault. In the cloud, those concepts, while they exist, you are told to plan around them by the cloud providers.
That's funny because usually when you think of the cloud, you're thinking of managed services, right? They'll maintain my 5 nines uptime. But here you are saying if I'm developing for the cloud, I'm thinking about failure. That's kind of counterintuitive. But I do see your point. And I guess I kind of agree. I definitely agree that it goes back to the application level architecture and how you're going to plan for this stuff to work and how are you going to deploy and how are you going to develop? How are you going to observe? All these things are done very differently on a traditional on-prem versus the cloud. And I guess you kind of got to talk about what private cloud really is, because if your private cloud is just, a server rack in the back of your store, then that's not really private cloud, right? Even if you're using those tools, maybe. But if your private cloud is a data center somewhere else or colo, and then you have a physical presence at each store, I think that's totally a viable private cloud. And what we do sometimes is we'll deploy like a Kubernetes cluster on the edge of every store. And then we'll do like a daemon set for a certain application. So it's at every single store like that. And that's all on-prem because we own all that infrastructure. We own all those stores, right? And it still allows us to use cloud native technologies.
I think going beyond the technology conversation we're having, like life's a bit easier. There's new abstractions being built on top of abstractions. And I think that changes the expectations on a cloud engineer or a platform engineer to be more business savvy, essentially, and connecting what they're doing with outcomes to the business. Like, I can't imagine, and maybe there is people out there who are cabling server rooms and we're also interviewing all the engineers at their organization to find out where their optimizations opportunities might be. And I think that's something to sort of think about as well. If you're going to move away from that traditional role to something more cloud-based, I feel anyway, because I've been a computer programmer for many years and I've been a sort of half-arse sysadmin for a lot of the time, that my role has changed hugely from debugging Apache instances and spinning up bare metal to talking a lot more with people and talking more about business outcomes. And that job demands a wider set of skills beyond technology. So it's also something to consider, but also a concern. Like, we're getting more and more abstractions. They're getting better and better. Some of these skills might become redundant. They don't always become redundant, but it's definitely harder. So I think with those levels of abstraction, we're getting closer and closer to business problems. So speaking that language and playing politics, sometimes those skills come into it too. That's the mind shift as well, I think, that people might need to feel and are surprised by when it happens.
Yeah, we see a lot of businesses moving towards a much more product-focused mindset, right? Where they're thinking about, this thing I'm building, what problem does it solve for the business? And where is my team building this specific product, adding value back to the business? And I guess in a more cloud-focused environment, like you were saying, Shane, your skill set of being able to SSH into something and know the key bindings for Vim or whatever is way less valuable to the business than your skill set in being able to deploy something that scales on demand and is reliable and is cost efficient, and all of the other non-functional requirements come with, I guess, being a platform engineering team.
I may be completely wrong here, but I've been reading a lot of CVs lately, and I've found that someone who's put down, I work hard and know Ansible really well, it's not really very compelling compared to someone who says, I've gotten the deployment frequency up by X% by doing Y. It's, I've gotten outcomes for this company, not I've done a thing in a tech. So yeah, something to bear in mind.
Yeah, and I think I found as I've been pruning my own CV, taking out references to I managed 500 servers, because that's sort of meaningless, right? That could have been 500 really inefficient boxes that I was just managing for the sake of it.
It's like writing, I wrote loads of code.
Yeah, exactly. And it's actually thinking about, well, I mentored a team of 3 tech ops engineers who were doing our deployments, and I helped them automate some of their workloads and reduce the deployment time down from 3 hours to 30 minutes. And that kind of thing that actually is delivering value for a business, rather than the I managed X number of servers, or I upgraded our SQL server, or I replaced some hardware at our DR site. Because that kind of stuff, just while it's important, is becoming less and less relevant for businesses operating in the cloud, I guess.
Presumably some of that is you both moving through the seniority of your industry as well. But I'm getting the sense you think that it's broader than that, and it's the whole industry shifting rather than just you moving up within it.
Absolutely.
Yeah, I mean, I've been speaking to a lot of junior engineers recently who have never even been in a data center, and they've got to a kind of not senior position, but a reasonable position of hierarchy where they're talking to customers, they're talking to engineering leads, they're talking to execs. They've never been in a data center, but what they've spent their career, as short as it might have been, 3 or 4 years until now, doing is understanding what the requirements of that customer is and translating those into deliverables for engineers, infrastructure people, whatever else it might be.
A valuable skill. And again, totally agree. I've been talking to a lot of level 1 engineers as well, and it's kind of tough on them. They have to learn a lot just to be a level 1 engineer. The cognitive load is very high as we shift everything left. It's no longer I'm expected to know Java, right? It's I have to know Java, and I have to know React, and I have to know Postgres, and how do indexes work, and how do I prune them, and stuff like that, depending on how managed it is.
With saying that, I get why the average engineer doesn't know what the inside of a data center looks like, or even knows how to spin up a server. Like there's just so many abstraction layers, and you've been handed these abstraction layers, and you're probably bombarded with all the information you need to digest just to do your job. You're not really going to go beneath those abstraction layers unless you absolutely have to. It's like if I was a Python developer, I'm not going to look at the C code underlying it or the assembly under that, not unless I ever had to. So it's probably kind of a similar situation they find themselves in, and it's difficult.
I guess the flip side of that is that it does make things much harder on you when stuff breaks. I've seen lots of cases over the last few years where, in your example, Sean, someone is a developer who's using Postgres. Something underlying in Aurora breaks, or they're troubleshooting this weird storage performance issue and they just can't work it out. And they're reliant a lot more on public cloud providers, support engineers to help them troubleshoot things like just basic Postgres logs, or looking at storage I/O and do they need to provision a faster disk? Are they hitting limits of what the CPU can do, memory can do? There are a lot of engineers that just don't understand that stuff anymore because it's so abstracted away. And for 90% of the time, probably fine. But for that 10% of the time where things are broken and you need to fix them, I think it still is a valuable skill to have.
This episode is sponsored by SysCloud. Companies big and small rely a lot on SaaS applications to run their business. But what happens when critical SaaS data is lost due to human errors, accidental deletions, or ransomware attacks? That's where SysCloud comes in. It's a single pane of glass to back up all critical SaaS applications such as Microsoft 365, Google Workspace, Salesforce, Slack, HubSpot, QuickBooks Online, to name a few. SysCloud also helps with ransomware recovery, identifies compliance gaps in your SaaS data, monitors for unusual data activity, and can automatically archive inactive SaaS data to save on storage costs. Plus, it's SOC 2 certified, so data remains secure in the cloud. Over 2,000 IT admins already trust SysCloud to protect their SaaS data. Head to syscloud.com for a 30-day free trial. And, for a limited time, use code HCS to get 50% off your first purchase. That's syscloud.com. Okay, so I want to work this through because I think we've talked about a few different pieces and I want to put them together. So there's this contention that a cloud-first professional, will say, thinks about abstractions and can target either on-prem or the cloud, depending on the use case, so long as they do that with the right mindset. We've also talked about how the junior engineers are expected to have much more understanding of things like products and business value and going higher up that stack. Now, presumably, there's a mix there of the abstractions taking some of the load and also someone else doing the work, right? Like some of those tasks have gone away in the cloud world because you're talking about scaling them up through an abstraction or you're getting rid of some of the details. But there's still servers that need to be maintained. There's still things that need to happen. So if we're talking about that happening in a private cloud, does that mean you can only be a cloud-first developer in the private cloud if you have SREs doing all the work that the public cloud would do for you?
I don't necessarily think so. I think there are a lot of people, companies, providers that will give you those services in your private cloud. There are a lot of colo providers that have kind of moved into the space of, we will look after the hardware and we'll provision VMs on it for you to deploy onto. That's a model I've seen. Equally, I've seen people moving to MSPs are looking after my servers and I'm just deploying code on top of them. There's, I guess, a bunch of different models, right? Platform engineering being another one of those, where the platform engineering team provide a set of common ways for developers to build and a set of common platforms for them to target. So we talk a lot about Kubernetes being a big one of those, where you give your code to a team. That code gets deployed in a pipeline, a container image gets built, it runs on Kubernetes. I think it's not just applicable to public cloud. I honestly believe that cloud mindset is something that can be done across both on-prem, private cloud, public cloud, whatever you want to call it.
Hybrid cloud. No, but I get your point, Aaron. If I want to deploy a Postgres cluster on my private cloud, who's going to do that for me? You'd have to have a platform engineering team who's capable of doing that or have created something for you to self-provision that versus just clicking on a couple checkboxes on the cloud or, any public cloud. So I get your point. And it's well taken. Yeah, you're going to have some, either an abstraction layer that can work between both the private and public cloud infrastructure that you have, or rely on some sort of third-party service to do that, or have to hire engineers to retain that talent, that knowledge.
And equally, there's a whole industry of products that have built up around it, right? So our favorite OpenShift is one of those. Things like OpenStack also do that. I'm sure there are a whole bunch of others where they have these pre-canned, I'm a developer and I want a highly available Postgres, click button type workflows that actually do work really well if that's the kind of environment you're in. But the bottom line is that, yeah, you do still need someone who's going to deploy, install, and run OpenShift, OpenStack, whatever else it is for you. And that might be a public cloud provider. That might be an engineering team that sits within your organization that is just in charge of keeping the lights on for those servers.
So I think then we agree. It's really up to, just like infrastructure as a service, platform as a service, right? Software as a service. It's really just pick and choose what flavor for what your company's comfortable with.
Well, it's interesting because I think you end up asking these questions from slightly different perspectives, because if you're really just recasting the work into different buckets, then it asks different sort of scalability questions. Obviously, it works if you're backing off to the public cloud because they have the scale to do all of these things and effectively do platform engineering at massive scale, and that works. But if you're talking about a handful of servers in a small company, now you could easily say that they just should use the public cloud. Fine, like that's one argument to that. But that does raise the question of whether in a small environment this approach does work. Or is there a certain scale you need to have to do cloud-first development on-prem?
Well, as with everything in hybrid cloud, it depends. Private cloud is meant for statically known loads, meaning I know that I'm always going to have this, minimum requirements. So I'm going to move it to my private cloud so it's the cheapest, it's the most efficient, If there's any data concerns, you can handle that at that level. But for anything that's going to be spiky or is an unknown or a proof of concept or whatever, that's where the public cloud exceeds. And it's all about knowing when to use which tool.
Yeah, and I guess that does sort of lend itself to size of team. If you are a 5-person development team, there is probably a strong correlation to number of end customers and number of requests that you need to handle. If you're in any reasonable organization that isn't massively overworking its developers. So yeah, maybe private cloud does lend itself a bit better there. On the flip side, you've got tons of work to do, and that work probably isn't best done managing the hardware. So there are arguments for both.
Do any of you see a situation where you would say that, okay, look, you've only got 5 physical servers. Don't worry about this whole cloud-first development paradigm. Just install some bare metal Linux and stick some Apache on it and go for it.
If you've got the person who knows what to do when everything goes to crap, and it's not the end of the world if it goes down for a while, yeah, I suppose. You take that risk, but you've got a hammer, not everything's a nail, I suppose, would be my mindset.
It's 2 different jobs. It's like 2 different complete worlds of experience. Sysadmin versus cloud ops. Not even cloud engineer, cloud ops. So if I had that handful, I would put Kubernetes on them and then go to town and have everyone deploy stuff the same way as much as I could.
Yeah, and I think you still get all of the benefits that you would of running those workloads in a cloud native way, even if you've got those 5 servers, right? You end up with things like daemon sets, like you said earlier, Sean. You end up with the isolation boundary that running in a container gives you. You end up with all of the networking and load balancing and all of these principles that we all like on your 5 servers by deploying in a cloud-like way. The flip side of that is you've got to understand how to manage all of the underlying cloud stuff, which is a lot more complicated than apt install nginx and whatever else it is that you need to do to run your application. Installing a LAMP stack is like 4 clicks in a task cell, whereas setting up Kubernetes and deploying nginx and MySQL and PHP and setting the build pipelines up and getting the containers working and deploying automatically if you're using GitOps is way more difficult than task cell and clicking LAMP.
But Jay had a good point. Shane said that abstraction layers are coming more and more. And nowadays, like to stand up Kubernetes is a bash command away, depending. It's either 1 or 2 commands, depending if you're going to pipe straight into bash. But I mean, yeah. And then a Helm chart that can do all those 3 things for you, depending on what you're trying to deploy. That's a lot less burden. But again, you lose the knowledge of having to operate that.
I think that if I lean into Aaron's example of you've got 5 servers, you're kind of, in terms of skill set, talking about the Ferrari bit. Yes, I can infinitely scale all of these things, but actually it's Alan or Anne in the corner who's doing a bit of desktop support and can click around in Windows Server or, maybe knows a little bit of Linux to do something. Like, are they going to invest in a Ferrari like yourself, Sean, for these 5 servers? That's a costly skill set. Probably wouldn't.
And I guess that's the other thing, right, is there are a lot of companies where their use case is the classic Windows small business server. We need email, we need LDAP, and we need a file server, and probably a database to put our accounting software pointing to or whatever it is. So for those use cases where it's like 1 or 2 boxes or a couple of VMs and maybe a virtual desktop that Sarah uses when she's working from home and remotes into, then yeah, maybe Kubernetes isn't the way to go for that. And actually sticking that on a couple of bare metal boxes running Proxmox may be easier for you.
It's all about what the goal is. What is the goal here? Is it for me to easily develop and deploy my software? Or is it easier for just to maintain my software, right? To maintain it. Because I paid someone, a contractor, a couple grand to set it up, and now it's done, right? And I just keep doing my stuff and I SSH and I put that on the server and, the update's done. If that's the use case there for your company and your workloads and use cases, then fine. But if you're going to be doing stuff above that and you want load balancers or any of the cloud native stuff, which the use cases are compelling, I don't know if you've heard recently, then you got to invest that time.
And I think we've all ended up orchestrating these large cloud workloads on-prem. and having to implement things like highly available load balancing or multi-AZ or multi-data center, I guess, as it would be on-prem ourselves, and can probably agree that doing that to the same effectiveness as a public cloud provider is really, really hard.
Really tough.
I think if you could, you'd be a public cloud provider as well.
Isn't that what that Lidl did?
Oh, the little cloud. Yeah.
There you go.
I'm looking forward to try that someday.
But again, not everyone needs that, right? I've operated pretty large-scale workloads on-prem across a couple of data centers and been able to satisfy the availability needs absolutely fine without having redundant dark fiber between sites and all of the fun stuff the cloud providers do. When it broke, though, it was my fault, and I couldn't just go, yeah, it's Microsoft's problem. It was quite a nice day to be able to do that when we did finally move to the cloud.
So that's the other benefit of cloud providers. It's just shifting the blame another way as well. Like being able to say, I don't know, sorry. And the amount of times I've been on a call with Amazon solution architects and they I don't know what they've got. They've got some sort of shell scripts or some dashboard I don't have that gives them better insights into these problems than I do.
Yeah, shifting blame left as well. That's not a bad thing to do.
Well, I think that about wraps things up. But before we go, just a thank you to our existing PayPal supporters and patrons. If you'd like to join those people, you can at hybridcloudshow.com/support, where for various amounts on Patreon, you can get an ad-free feed of either just this show or all the Late Night Linux family shows. And sometimes you receive episodes early. If you have any questions or feedback, then please do send those in to show@hybridcloudshow.com. We'll be back in 2 weeks. Until then, I've been Aaron.
I've been Gary.
I've been Sean.
And I've been Shane.
See you later.